Hello my good friends, before I want to start, I want to thank NASA for going up there and discovering that electron flood theory is real. And electronic flood theory says that there's only electrons exist. We call them electrons. They're the smallest particle. All right? They are dipoles, and they have approximately that much weight. Electrons are dipoles. They have a plus and a minus. They have 1 electron volt of energy. Photons are two of those electrons back to back. They look exactly like that, and we have them exactly like that in pictures. Protons are 1,835 electrons in a ball that looks something like that, and that would be a proton. Add one more, and you have a neutron. And when one breaks off, it goes back to being a proton. That's what they say, and I agree. Isotopes are extra electrons. So if you have 2 or 3 extra electrons in here, you have a little radioactive isotope, and it will fall apart because they don't want to be there and they're not resonant. S orbital atoms are anti-gravity. They don't have enough electrons to get pulled to the positive Earth. And the Earth is positive, absolutely no doubt whatsoever. Take any electricity, put it next to the Earth, bzzz, it goes right there. Static electricity collects on you, it's in the air, you go to the ground, zip, right to ground. They call it Earth ground. Electrons want to go there. It is a positive, attractive source. Now, and the s orbitals don't have enough electrons, hydrogen and helium, they don't have this, so they go up in the air. Now, they're not sucked to Earth magnetically. That's what gravity is. There's nothing more than gravity. The more electrons, the harder it hits the Earth. Now, electrons are intelligent, just like ants are. And the bottom line on that is that they have to be able to do what they have to do in the region that they find themselves in at any particular time. And it's basically called quorum intelligence. If there's enough of them together in the right place at the right time, they know what their job is. They do the job. All right, before we start, don't forget now, the sun isn't just sitting here and everything's spinning around the sun. The sun is flying through the solar system on the arm of the Milky Way, right? One of the arms of our galaxy. And it's whipping around the solar system, our galaxy, and all of the planets in our solar system are following it and spinning around it as they go forward. So there's this and there's this. Now, let's see what they have to show at NASA. Before we go do that, I haven't looked at that video yet. And what my contention is that the sun is crushing through all these particles that are out there, because there's nothing but a bazillion particles everywhere. They're dark. And it is the dark energy, and it is the dark matter, and we're hitting it. When we hit it, it concusses, and it becomes a magnetic opposition. So what it is. And that creates the intense region, what's called the corona. All right, so this is the NASA releases. This just happened today. Now, there's 4 hours ago and 3 hours ago. Let's look at what they have to say 3 hours ago. All right, here's where it gets really interesting. Here's where I really think I understand this. Now, they talk about a breaking point. All right, now.
Parker found a transition point in the solar wind. The corona is the sun's faint, outermost layer that
All right, remember this. The corona surrounds the sun. And it's like what we call our magnetosphere or our ionosphere, that range, which is the furthest out range of our atmosphere. Now, and I'm going to explain this in a minute, and then out here is where they say it sweeps away with the solar wind.
Transitions to the solar wind.
All right, so it's like this. Now, here's what I want you to remember. The sun down here is, I believe it's about 6,000 degrees. I believe that's Celsius. I'm not certain of that, but let's say it's 6,000 degrees. Out here, I know this for a fact, is millions of degrees. Now, how did it get so much of a difference and change? 6,000 here, a million up here. Well, how did that happen? The reason it happened is that this is crushing into particles that are resisting it. They're opposing it, creating heat. And because they additionally are all the same particles that are coming at them, they oppose each other. Every particle that we have opposes each other in volume. In singularness, they attach upside down, back and forth. They're dipoles, and when they hit this way, they bounce. When they hit this way, they attach. And at a certain resonance value, 1836 for, I believe it's for neutrons, 1835 for protons, right in that range, that's when they become stable. And when they hit that range of stability, they really fight for that region, and they force themselves through. They're called protons. All right, and you know that's a chunk of something. Now, if photons are much smaller, those are just two back-to-back electrons, which we call electrons. Really, they're dipoles. So you have one this way, and then one coming the other way, upside down, bang, and you have that. You have a back-to-back dipole, which gives you a photon, which is it's a chunk of matter. Really, it is. It's a particle, and it goes through space. And because it has zones of positive and negativeness to it, it affects the space it goes through and creates fields. All right. So here's the sun. It's cascading through space, crushing against the particles impacting in it. Still nothing makes sense until you realize that the atomic model is not correct. It can't possibly be correct. According to my calculations, it just doesn't make any sense at all. First of all, you can't have anything that's just a plus or a minus for any extended period of time. So electrons cannot be just a negative particle. I did see charge separation in our experiments. I was very surprised, and I'll show it to you. But normally, every particle is going to have a plus and a minus to it. And even your electrons, okay, so they cloud the nucleus, which is another pile of positives and negatives, just like this, right? Every one of these balls is one of those. It's got a positive and a negative to it. That ball really would look like this. It would have a positive top to it like that, and then it would have a negative top bottom to it like this. That's really what you're looking at. And that is it right there. And as it spins through space, it flops its fields around. And when two of them add together, you end up with this. And then you still have this. And I can show you all this in the experiments that Rod did with the Venturi. Now, then you get into your protons. And your protons is just a ball of these particles. And there's 1835 is stable as a proton. All right? 1836 is stable as a neutron. Those are the two very close zones of stability. And then as you go up through all the different particles, you can have 1850, 1870, 1890. It's going to fall apart. That's called nuclear radiation decay. They fall apart. They're not stable. They're not resonant. Hydrogen is literally the one proton, 1835 particles like that, and one more electron out here. All right. This is called electron flooded core. It's electron flood theory. And it just says there is nothing but electrons, and electrons are these. They're dipoles. There is no singular negative anything. A singular negative is going to have one side of it's going to be positive. It's just having like a piece of paper and there's no second side to it. It's impossible. All right, I said I've seen all of these different interactions, and I have. And these are the light experiments I did with Rod Warren. That's a pulse red laser. These are glowing little particles we call ether, which everybody called it in the past. This is an accelerated light, and that is the particle. It is actually a particle. It is not a wave. It is a particle. It creates a wave just like a jet fighter does, but it now has accelerated, so Einstein was wrong. It is a particle. They were all wrong. It is now concussing and glowing and turning into what I call Cherenkov, well, I guess they call it Cherenkov radiation too. These are the repulsion patterns, not interference patterns. These are patterns created by particles that want to be away from each other, not because they're banging into each other. These are what they apparently call Higgs fields, and this is what's called the bosons. And these fields surround these particles. And I believe this is scalar energy, which is sideways energy, not straightforward. Now, this is a new particle nobody's ever seen before except Rod and me. And, of course, I've been showing it all over the world, but nobody's taken any serious interest. And I don't know what it is. And this is the particle that I showed you before, which I believe is a photon. It's an up and a down electron. There's two, I told you, these are the protons. There's a whole batch of them. When they get smashed into little bits and pieces, they fly off as photons, and the two of them together are photons. One up and one down, side by side. This one goes up and this one goes down, and they glue together and they become basically a neutral particle, but it's a mover, and it still has, it's a bar magnet, right? So it's not like some singular particle. Nothing is singular. I can't, it just doesn't make sense, that particular theory of only electrons. And then the other theory about just a gigantic proton, absolutely, it's impossible. The isotopes would not work. You can't have gigantic protons, gigantic neutrons, and then have 38 isotopes for lanthanum. It's insanity. Now, this is the particle that's spinning to the right, drifting to the left, compressing as it goes forward. Now, I have one more to show you, if I can remember what I wanted to show. Oh yeah, this is the charge separation. This one here has got me perplexed. Now, I told you that nothing is one-sided, and that's true forever. Now, and I don't know how this happened, but I can tell you, I can see it. That's that particle. That's the light particle. And we saw it. It has a dark and a light, dark and a light. Okay, now, what is this? There's the dark, there's the light. Zero darkness, a lot of darkness. Darkness coming back in. Where did that come from? How does that happen? That's really got me. Every time I think about it, that's how I end up speaking to myself. I have no idea. Look at that. Look at that. I don't know if you can see it as well as I can that, but there's an interaction there that is just mind-boggling. How did the blackness get away and stay away and turn into whiteness and then turn to blackness, come back? If there's some particle physicists that think they can understand this kind of stuff, come on down. I'm here. I'm waiting. Rod can do this all day long. I mean, he did this for well over a year, and I mean every day, all day long. It seemed like I saw more pictures of these kind of things than you could possibly imagine. Anyway, I'm going to leave it at that, or I'm going to go forward. That's how I do things. I'm never sure.